Hey, what's up, guys? Okay, so in this video, let's prove the fine communication lemma. And if you haven't seen my previous video, that you need to check it because there's a previous lemma that we will use. So basically, let me just quickly say it. So this tells you that if you have skin and you have two intersections, two affine open subskin, then every point in this affine open subskin admits open cover. That open cover is amazingly the distinguished open set for both subskins. So basically, for every P belongs to U intersection B, there's F and A and G, F in A, G in B, such that the P belongs to D of A of F and the D of G B. Okay, so let's talk about affine communication lemma. So affine communication lemma. Since we have previous proof, right? Previous tool, so it's very simple. Okay, so there's so let's define affine local. So if there is a property P, we call affine local. The first one is that, right, so if affine spec A in X, let's say OX is a skin. If you have a affine subset in X has property P, then all the small or distinguished open subset will have. Okay. So basically it says that the spec AF has P. Okay, basically say, or another way to saying that each small distinguished open subset D of AF has property P for all F. Okay, then the second one is that if each smaller one has this property, then the total will have this property. Okay, so let me just write down. So the second one is that if let's say if I write IA into the F1, F2 up to Fn, and if for all spec AI goes into X has property P has P, then X and spec A has P. Okay, so basically it just says very simple, right? Affine local just saying that if the global affine open cover has and DF has property P, if then each smaller one, if all the smaller one have property P, then the larger one has the property P. Okay, so okay, so that's theorem. So this is called affine communication lemma. So if let's say, so if X is union of spec AI, I can be arbitrarily large. Sorry. What the hell is going on? What the hell is going on? Okay, so if X is this, and all the I can be arbitrarily large. If for all AI or all spec AI, let's say all spec AI in X has P, which is affine local, then every open set has every open affine cover has property P, and every spec R in X has property P. Okay, so this is very powerful, right? This tells you that if you have a affine local property P, if you can prove a affine local property P on some special affine open cover, then every spec R, every another affine open cover will have the property P. Okay, so proof. Very simple. Okay, so very simple. Very simple. So the proof idea is the following, right? So idea is the following, right? You start with let's say R, right? So this is a spec R. And then we know that the spec R, right, is definitely covered by this spec AI. Okay. So basically, this tell you that this tell you what? This tell you that right. So you can let me spec R, right, can be separated into, let's say this is the maybe this will cover with A1 or this maybe A2 or A keep going, right? Okay, so the idea is that okay, so for every P belongs to spec R, and so basically we need to show that what the hell is going on? Okay, so for every P belongs to spec R, and by the intersection lemma, right? Sorry, for every P belongs to spec R, there will be I belongs I, such that P belongs to spec AI, right? So that means P will belong to spec AI intersection with spec R. Okay, but there is a distinguished open set where there's in AI, right? By the previous lemma, by this intersection lemma. As I show, there is a simultaneously, right? If you point P here, there is a simultaneously distinguished open set of A. Right, so there's an intersection lemma. By this intersection lemma, there's a distinguishable DAF, where F, right? F belongs to AI. Okay, so DAAF will cover P. This is band notation. That's using Y as our point. Y. Okay. Okay. So that means what? That means that your spec R is covered by is covered by what? Okay, it's a subset of but you can see this distinguished open subset is actually also in R, right? Also in R. So that means that your spec R can be written as the union of this distinguished open subset. Okay, so that's just using GI. Okay, for each point, right, you can find the intersection. You can find some AI. You can find some AI such that this point Y will have the distinguished open subset where inside AI and also inside spec R. Okay, so your spec R now is a union of DGI, right? And each DGI will be a subset of some spec AJ or whatever. Okay, so by one, we're affine local. We know that the spec AJ has property P. So this tells you that the DGI has property P, right? So each will have property P, but spec R is the union, right? So by two, spec R should has property P.